Audio Jungle.
Hello everyone, welcome to Wi-Fi Learn. In this video, we can see some basic electrical quantities definitions and their units. The first electrical quantity we are going to see is charge. A charge is a physical property of matter that experiences a force when it is kept in the electromagnetic field. That is, charge is a quantity of electricity which flows in the path of an electrical circuit for a particular time. See, it is the definition of charge. It is a physical property of matter that experiences a force when it is kept in the field. The field can be of electromagnetic field. Charge can also be defined as it is a quantity of electricity passed in the electrical circuit for a particular amount of time. Each element has a charges in it. The two types of charges are positive charge and negative charge. Positive charge is termed as a proton and negative charge is an electron. Proton and the electron. The two types of charges are positive and negative. They are also called as ions. Positive ions and negative ions. Unit of charge is coulomb. Let's see nature of the charges. In this picture, it shows that opposite charges attract each other where like charges repel each other. In first, positive negative attract, whereas in the like charges positive positive, negative negative repel each other. This is the nature of a charges. The charges generally exist in two types. One is positive charge and another one is negative charge. Positive charge is a proton and the negative charge is an electron. The notation of a charge is E. It can be either an electron, either a proton, but the notation of a charge is E. When the element has fully negatively charged ions, then the element is termed as negative conductor. And when the element has only positive charge ions, then the element is termed as positive charge conductor. When the elements have equal amount of positive and negative charges, then the element is termed to be as neutral. That is, it is in the region between the positive ion and the negative ion. Neutral is a region between positive ions and negative ions. It is not a third type of an ion, but it is a region between the positive ion and the negative ions. The value of a single charge is given as, that is, 1 electron or 1 proton. If it is a proton, it is 1.6 into 10 to the power minus 19, and if it is electron, it is minus 1.6 into 10 to the power minus 9. It is for electron and proton. And neutral can also be defined when the net charge of an object is equal to 0, then the object is termed as a neutral. Okay, then the object is termed to be in the neutral state. Charge particles can be produced by rubbing suitable materials which shows the existence of charges. For example, if you rub comb on your head and if you take that comb and keep it in the place of pieces of paper, the pieces of paper would attract to that comb. It shows that there is an existence of charges in the comb after rubbing on your head, because in the comb will get a positive charge after rubbing on your head, so that positive charge attracts a negative charge that present in the pieces of paper. Okay, this is a simple charge particle production you would have learnt already. This is a charge particle production. Example is comb rubbed on your head and attracts pieces of paper. Now let's see properties of charges. The properties of charges are additive property or addition of charges, and the second is conservation of charges, and the last is quantization of charges. Let's see the first property, addition of charges. Consider in a system, if a system has number of charges as Q1, Q2, Q3 and goes on, and the total amount of charges that present in the system would be addition of all charges. So that the Q total is represented as sum of the all charges that present in the system. Okay, this is the addition of charges property, and second is nothing but a conservation of charges. Conservation of charges similar to the conservation of energy, that charges neither be created nor be destroyed. So the conservation of charge defines it transfer a charge from one form to another form. That the charge can neither be created nor be destroyed, but it can transfer from one form to another. Let's see with an example. I am taking two elements, one is full of negative charge and one has no charge. If these two systems are kept close together, the negative charge that present in this charged element would transfer to this element which has no charge. Hence, the charge can be transferred from one element or one form to another form, but it cannot be created, neither be destroyed. Okay, this is a property of conservation of charges. This charge is moved to this element which has no charge. So finally this element would be of negative charge. Transferring of ions. Now let's see the last property, quantization of charges. Quantization of an electric charge can be given by an equation Q is equal to N into A, where N is an integer. It can be of 0, negative or positive, where N is an integer. If N is 0, then electric charge present in the element would be 0, so the element is termed as neutral element. When N is negative, then the charges present in the element would be of negative charge. When the N is positive, the charges present in the element would be positive, then it is positive charge. E element represent whether it can be of electron or a proton. It has a value of 1.6 into 10 to the power of minus 19. Okay, normal value. 1 coulomb is defined as a measure of quantity of electricity that passed in an electrical circuit in 1 second. A quantity of electricity passed or quantity of charges passed is termed as a current. So 1 coulomb can be represented as 1 ampere of current flowed in 1 second. Got it? 1 coulomb is defined as a flow of electricity of 1 ampere in 1 second. The value of 1 coulomb is nothing but it could be calculated by the quantization of an electric charge formula, where coulomb is represented as Q N into E. We need number of electrons for 1 coulomb, right? So the number of electrons, the integer value, the number of electrons for 1 coulomb can be given as N is equal to Q divided by E. The Q is 1. We know the value of ions, that is 1.6 into 10 to the power of minus 19. That would give the value of 6.424 into 10 to the power of 18. The number of electrons that present in the 1 coulomb of charge is 6.424 into 10 to the power of 18.